It's either called a parting tool, a cutoff tool, or a groove tool. They're all one and the same here. And what that tool looks like is it's specific to your machine here. It's going to be this guy right here. So this here can go and we can create OD grooves with it by plunging in the cross slide orientation or the x-axis. And it does not cut sideways. You can only plunge this direction, then you have to move out, move over, and cut again. Out and over and cut again. So that's how this tool will work. Now just by looking at this right now, I feel like there's a lot sticking out here, so I'm going to make a little adjustment to this. The right Allen wrench, and make this scoot in just a little bit. If you want something to cut better, you need to have it as rigid as possible, and by having more material sticking out like that, it's just going to have a chance for vibration and chatter. So we stub this up a little bit more, and for what we're doing, this should help us out a little as far as cutting. All right, happier with that now. And I put this on here and we can see, well, remember we had this oriented earlier for our turning tool. We needed to lead it a little bit. But right now we want this tool to actually be perfectly at 90 degrees. So to verify that, what I do here, loosen this nut up on top and get it close. I take this right up against the chuck face itself. So I'm gonna put the chuck in neutral. And I'm going to freely spin this, and I'm going to take a steel rule, which I have sitting up here. I'm going to put that up against the tool itself, and I'm going to bring the carriage in. I'm going to make contact with that chuck. If I do that, this is all free floating right now, I can square that up right against the chuck face, and now when I tighten this, I know for certain that I am perfectly perpendicular to that face, which makes me perfectly perpendicular to my cylinder, which is where I want to cut at. So I'm happy with that. Put that back there. Now what I need to do is, according to my blueprint, and I'm going to make you do the math on this, but what it's going to come out to here is I need to make this groove from this shoulder here. So I'm going to take my cutoff tool and I'm going to touch off of this shoulder that I have right here. And then I'm going to zero out my travidile and I'm going to move it out 250 thousandths, and then I'm going to zero it again. Then I will start my plunges of where I'm going to cut at. So for starters here, bring this in and we just very gently come up against the shoulder and square off. We're good. Now I'm going to zero this out and I'm going to make this read 0 and 0. Now I know that I want the groove on this side to be 250 thousandths away from that shoulder, so I need to move this in the positive direction 250 thousandths. So remember the positive direction, we read the red numbers. So if I go here, there's 20 thou, there's 50 thou, there's 100 thou, and if we just watch here, there's 200, and then there's 240, 245, and that is 250 right there. So that is where I want to make my groove cut at. Now to make life simple, an easy number to work off of is 0. And there's no reason that I actually need to move into that shoulder again. So I'm going to re-zero this right now in my new orientation. So I'm going to go down here. That's pretty zeroed. And 0. All right, I'm happy. All right. So now what I need to do is move over, and I'm going to do this for you because otherwise it's not going to make any sense. So on my blueprint here, 11/16. Figure out what 11/16 is in decimal. 11 divided by 16, 687. So that is 687 thousandths is how wide that is. Now this is where it gets interesting. Is I'm going to be cutting this with my groove tool. And I'm just going to give you a little visual by pulling this out here. If I take my tool and I zeroed here, which I did on that shoulder, I moved it out 250 thousandths, so I'm right there. So that's where my 0 is at currently, and if I were to move it exactly what it says, 687, watch what happens if you look closely at the drawing in my tool. 687 thousandths is going to bring it to here. Well, if you notice, the problem is it's going to be too wide. It's going to dig in to that shoulder right there by exactly the width of the cutoff tool. So what I need to do is actually verify how wide is this cutoff tool. Well, I go with my trusty caliper. And I measure and I say, okay, it's 125 thousandths. So underneath it here, set this back down. 687, but I want to subtract 125 thousandths off because I don't want it to be too wide. I want it to measure 687 from shoulder to shoulder. So I say 0.687 minus 0.125, and my net is 562. That's the number that I'm going for of how far I should move from this shoulder over to this one to ensure that the 687 comes out correctly. So you might watch this part a couple times in the video just to understand where all that numbers came from. All right, so right now what I like to do as well is I like to get a visual representation of where we are. Let's turn this back to 250. Right at 0, I'm gonna make a little mark so I see where the far side of that groove is at. And then I'm gonna move over 562 thousandths, and I'm going to make a mark there as well so I can see where each side of the groove is going to be. So you can count this on here if you want to. I mean, there's 0, so there's 100, 200, 300, 400, 500, 550, 560, and again we're reading the red, 62. There's my location of my far side of my groove. And I'm just gonna go in and make a little scratch there. Now I know where each side of that groove is going to be, and then I just need to knock out all the material in between there. Now just for fun, we're gonna go here and measure with a caliper, and we're gonna see how wide we truly are here. So I'm gonna use the ID ears and just kinda visually set this up against here. So there's one side of the groove, here's the other side of the groove, and you can see that, yeah, we look like we're about 680, 682. In the ballpark for sure. We wanted to be 687 there. So that is why we did that. If I would have went over exactly 687 as far as where that tool was touched off, because it was touched off on this side here would have overcut by the width of that tool. So that's why I needed to shorten that distance. So from here, we know right now that our diameter of this measures 1 inch to 46 on this side. Okay, so I'm gonna touch this tool off on the diameter of it. So if I touch right here and just make contact, right there, I'm gonna zero out my cross slide. This is going to put me at 0, or basically right now, I'm at 1 inch to 46. So a full revolution on here is exactly 250 thousandths. So if I was to make almost a full revolution on here, in theory, that's where I'd want to be to make my cuts. So that would mean I'd press this in, basically a full revolution minus 4 thousandths. So I'm gonna go here and I'm gonna go back to my original 0, get myself lined up, but then verify on here that, hey, 0 is actually right there. And I'm gonna plunge this. So there's my 0 point, and I'm just gonna make cuts. A little bit of coolant. So there's 125. I wanna go almost all the way around, just shy. And I'm just gonna go right here to that number. I'm about 5,000 short right now. So I went 245 thousandths in, and you can see what I created. I can't move sideways with this tool.